Dependencies are often one of the more annoying parts of designing a system, and OOD does not make this any better on its own. If a class has many dependencies, it loses some of its flexibility and becomes coupled to those dependencies. If a class has no or few dependencies, it's considered loosely coupled, and it's often much easier to test since you don't have to worry about trying to mock out a hard-coded class. And by dependency, I mean any file or class that your current class needs included to be able to run. Let's start off with this basic example. We have 5 files we need to look over. The first one is example.php to get a feel for what's going on here. We require our table printer, logger, logger echo out, product, and purchase manager. We'll instantiate a new purchase manager and some products, and then we'll purchase the first and second products at full price, followed by the third with a 50% discount. Then we'll spin through our purchase history and output everything to a table. When we give this a try, we do indeed get our table, but along with something extra that seems to resemble log statements. Let's open purchasemanager.php to see what's going on here. In the constructor, we can see a new logger instance being stored, then products are being added to the purchases array, followed by being logged by the logger instance. Our discount purchases also send a log message out alongside of the purchase log message. When we inspect the logger class, the constructor creates a new instance of logger echo out, then calls the log method on it, passing in the formatted date and the contents for logging. At our last stop down the rabbit hole, logger echo out has a single method named log that, as it may be assumed, echoes out the data being passed in. So now that we know the source of our mystery log statements, we can take a quick peek inside of product.php, which we can see is just a simple entity and is being treated like a value object. On top of that, it has no setters beyond the constructor, only getters for the 2 properties. Simple enough. Now let's refocus on how to remove some of the hard-coded dependencies. Let's start with logger. Right now it requires that logger echo out be present inside of the constructor by hard-coding an instance of it to this logger. This would be a good and very simple place to introduce dependency injection. If you're not super familiar with dependency injection, you likely have a discomfort at the term and may think it's something way beyond what it really is. Dependency injection simply means that we can remove hard-coded dependencies like echo out and inject them back into our objects by setting them in the constructor or a setter later. And that's really it in a nutshell. Like anything, you can take dependency injection quite far and start making it seem more complex with things like DI containers, but we'll worry about those next episode. We can clean up this code very simply at this stage by passing the logging driver to the constructor rather than instantiating a new echo out instance. And then we'll just set this logger to be that instance. And that's it for this class. That's all it took. Now a logger instance no longer relies on echo out being present, and its implementation can be swapped out at any time. If you remember last episode's discussion on duck typing and polymorphism, this is another real-world use case for these. This makes this class feel a bit lighter and doesn't seem to lose its ability to inform us of what's going on here. We store a driver as a logger and then log data to it. We can even expand upon this later to allow multiple drivers to be added to logger, so we could store it to monolog or email or anything. And this is where abstraction and encapsulation can really help out in OOD. Okay, since logger's dependencies have been removed, we should jump over to our unit test to make sure everything's still working. We just have a single test in here. Test can make purchase, which creates a new purchase manager, adds a single product, and ensures that the purchase history only includes that given product. So let's run this to see if we broke anything, which of course I did because I need to pass logger an instance of which driver to use now. So let's open up purchase manager next, and then in our constructor, we'll inject a new logger echo out instance inside of logger. Rerunning our test shows that this has fixed the problem, but have we actually made the system less complex? Logger was cleaned up, but now Purchase Manager has 3 dependencies, so in theory it has become more complicated to reuse. This might not actually be a problem, but let's see if we can do anything else to remove some hard-coded dependencies. The first and likely most obvious solution is again to shift the logger dependencies over to the main file, so let's try that. Let's cut the instantiation of logger out, and then replace that with the variable logger, which we'll pass into the constructor. In example.php, we'll make the variable logger, and we'll paste that line that we just cut out. Next, we're going to pass in logger to the purchase manager. Now if we save and execute the script, we can see that everything still prints out as expected. If we run our tests, we get a red light, so let's alter that a bit. We'll create a mock in PHP unit and tell it to stub out the log method. And now we'll pass this into purchase manager, and if we run our tests again, it's all green with no additional console output because the log method is essentially doing nothing. So this is still an improvement, and we've made the code a bit more testable. But now we've kind of exposed an optional dependency as a required dependency, since constructor dependencies are generally considered required since the object cannot instantiate without them. We have a few options of changing this up a little bit. Let's take a look at a fairly simple fix. In Purchase Manager, let's set the constructor argument to optional, defaulting to null. Next, we'll create a protected method named log, which will take a single argument message, and inside of it we'll say, if this logger, then return this logger log message. Finally, we'll swap all calls to this logger log to simply say this log. If we run our tests again, we can see the green light, and if we run the example, we can still see our logging outputs. I'm not entirely sure what this pattern is called, but I'm inclined to call it a null method or a no-op wrapper, because we're essentially wrapping the dependency in a method we control directly, then using the dependency if it exists, else we're turning the action into a no-op. Pros to this implementation are that it's simple, fairly obvious as far as behavior goes, it allows for a simple abort if the dependency isn't set, and it isolates the conditional inside of the object it's being used with. Cons are, you're doing code branching depending on whether the dependency exists or not, potentially obfuscating some of the use of a collaborator or the use of a dependency. You're potentially wrapping an extra layer of complexity over something that's already using perhaps a strategy pattern, like we are here. Let's take a look at another approach. Let's undo our changes, remove the constructor argument altogether, and we'll instantiate a null log object set to this logger. Then we'll define the null log class above our current class. And it's going to have a single method log that accepts a message argument, just like our logger object. Finally, we'll define a setter on our Purchase Manager class for set logger. That will allow this logger to be set after instantiation. Now if we change the tests and remove the logger from the constructor, we can see we're still green. And then if we pass in our mock logger to set logger, we are again green. So this looks pretty good. Next, let's try running our example. If we run it as is, we get our output without any logging. So let's take this out and we'll pass in the logger to the set logger method. And if we run it again, our console logs are back. In here I used two different techniques. First, I showed an implementation of the null object pattern. That is, an implementation of an object that provides some sort of null behavior. It's essentially like you're mocking out an implementation like you would in a test, but it's for actual usage. Sometimes it's used for avoiding conditional logic, other times it's used just to keep a unified interface, and oftentimes these two are not mutually exclusive. It's a really great and simple pattern for keeping your code clean. The second pattern, or concept rather, is setter injection. Since the logging feature is optional, we are providing a coherent default, the null object, for our logger object, and then allowing the logger to be swapped out with another implementation after instantiation. This could also be adapted to something like addLogger, where we would allow multiple logging listeners to be added and spun through with another method later. There are some good write-ups out there on good use cases for constructor versus setter injection, Martin Fowler's blog being one of them. Now, if you'll notice, I did indeed add another hard-coded dependency back into Purchase Manager, the null log. This is one of those lovely trade-offs I've been mentioning throughout the series. There's absolutely nothing wrong with setting a base implementation via a hard-coded dependency, especially if you allow the option to change it out later. It keeps your objects testable and flexible, while still allowing for sensible defaults and a clean interface. It might not be suitable for all cases, but for many it's quite valid. It's one of those things that the developer must evaluate and decide on based on the requirements and largely experience and instinct. The same could be said for the product entity dependency. We could allow for some sort of factory that knows how to create objects for purchasing, and while this would increase testability further, again it's another trade-off. If your Purchase Manager will only be used to create products, the abstraction is extra overhead. If you can purchase multiple different items of products, then perhaps a purchasable product factory could be used, or the implementation could be changed to remove the need for the dependency at all. The choice is yours, and you must weigh the pros and cons to figure out what works best. Be practical and pragmatic at the same time. Next episode, I'm going to give you a brief introduction to a third form of dependency injection using dependency injection containers.